Now, the next thing was, how do we handle 1 minus cosine t over t as t approaches 0? And again, leaving the details to you to sketch in as you see fit, let me point out simply what the mathematics involved here is. You see, what we can handle is sine t over t. That means that what we would like to do is whenever we're given an alien form, we would somehow or other like to figure some way of factoring a sine t over t out of this thing. When you look at 1 minus cosine t, the identity sine squared equals 1 minus cosine squared t should suggest itself. Now, how do you get from 1 minus cosine t to 1 minus cosine squared t? You have to multiply by 1 plus cosine t. And if you multiply by 1 plus cosine t upstairs, you must multiply by 1 plus cosine t downstairs. By the way, the only time you can't multiply by something is when the thing is 0. You can't put that into the denominator. Notice that the cosine t is not 0 in a neighborhood of t equals 0. See, cosine t behaves like 1 when t is near 0. So this is a permissible step in this particular problem. The point is, we now factor 1 minus cosine squared t as sine t times sine t. See, that's sine squared t. We break up our t times 1 plus cosine t this way. Now we know that the limit of a product is the product of the limits. This we already know goes to 1. And as t approaches 0, from our previous limit work and the like, notice here the limit of a quotient is the quotient of the limits. The numerator goes to 0. The denominator goes to 2, because as t approaches 0, cosine 0 is 1. At any rate, that's 0 over 2, which is 0, and so this limit is 0. Now, at the risk of giving you a slight headache as I take the board down here, let me just review what it was that we did. You see, notice that without any knowledge of these limits at all, we were able to show that whatever the derivative of sine x was, it was this particular thing here. Now what we've done is we've shown that this is 1, and we've shown that this is 0, and using our limit theorems, what we now see is what? That if f of x is sine x, f prime of x is cosine x. And let me just write that down over here. That if y equals sine x, dy dx is cosine x. And again, notice how much of the calculus involved here was nothing new. It goes back to the so-called baby chapter that nobody likes, where we go back to epsilons, deltas,